Hello, Geert. First of all, I want to thank you for taking the time today to, really get into the details of your theories and issues with this vaccination program, with this pandemic, and the SARS coronavirus. So thank you for taking the time.
You're very welcome. Thanks for having me.
And for our audience that's watching, and as you know, you are in Brussels, Belgium. I am in Austin, Texas. But through the magic of filmmaking, we're sort of sitting in the same room virtually because I wanted to put out a video that really feels more intimate because we're going to get very intimate on this conversation. So to begin with, I have done several shows now on the different interviews you have done over the last almost half a year, last several months. You put out a video very early on from your own social media page warning the WHO that there was a real problem with the approach towards the SARS coronavirus or SARS-CoV-2.
Dear colleagues at the WHO, my name is Geert van den Bosch. My background is veterinary medicine. I'm a certified expert in microbiology and infectious diseases. I have a PhD in virology, and I have a long-standing career in human vaccinology. I'm urging you to immediately open the scientific debate on how human interventions in the COVID-19 pandemic are currently driving viral immune escape. I'm urging you to invite me for a scientific hearing open to the public and to scientists all over the world on this very topic. Ignoring or denying the impact of stringent infection prevention measures combined with mass vaccination using prophylactic vaccines is a colossal blunder. Please do listen to my cry of distress, and let's first and foremost deliberate on a scientifically justified strategy to mitigate the tsunami of morbidity and lethality that is now threatening us. And let's meanwhile devise a strategy to eradicate the steadily emerging highly infectious variants. On behalf of humanity, I sincerely thank you for considering my call.
To begin with, this time, I want to start out with sort of your background. What is it specifically about your experiences that is giving you a different perspective than we're hearing from other world-renowned scientists?
Well, Del, I think it has, in fact, more to do with what I decided back 10 or 12 years ago, where I decided I would take a completely different approach to science. But it started all with my intention that I would start all of a sudden to look at the science not as, an objective in its own right, but as a tool to solve problems. Because I was really very much bothered, having worked in both academia and in industry, I started thinking more and more about these two different worlds that both start with P. The world of the publications, that's what counts in academia, and the world of products, that's what counts in industry. And in between, everybody talks about translational medicine, but it's very, very rare, in fact, that we find solutions, that we use the science to really solve problems. And of course, my background is veterinary medicine. That's very broad, that's very diversified. And I had a chance during my career to touch upon several different fields. I specialized in virology, in vaccinology. I learned my vaccinology, in fact, in industry. That's also the place where I learned immunology. I was teaching zoonosis, so infectious diseases that can be transferred from animals to humans at the university. I have a long-standing interest in evolutionary biology, and all this has to do with interactions between the pathogen and the host. So the host immune system, and understanding these interactions is very, very important. And then what's also very important is to understand the evolutionary capacity that a pathogen has when it is put under widespread immune pressure. That is something you don't have in clinical studies, for example, right? This is the population effect. And so this simply illustrates that you have to be able to draw from all these several different fields. I was so fed up that we put many products in the pipeline in industry without even understanding how they interact, how they work exactly. And I was so fed up in academia that all what counts is publication. We need to connect both, because otherwise we are in a situation right now where we put out products without understanding what's going on, without understanding the pandemic, and you know my point. I'm 200% convinced that this is going to lead to a catastrophe, to a disaster.
Geert, you worked for Gavi on the Ebola vaccine program. You've worked with the Bill and Melinda Gates Foundation. Now, obviously, you didn't start out by deciding to put your career in jeopardy as a world-renowned, vaccine maker, as a scientist, as a professor. You must have reached out to your peers at the WHO, who I know you've worked with before, at Bill and Melinda Gates Foundation, at Gavi. How did you reach out, and what was the response?
Well, I've reached out at least 3 times to, I would say, all the global health authorities, a number of public health authorities, CDC, NIH, the Bill and Melinda Gates Foundation, WHO, of course. And I got maybe 1 or 2 anonymous responses. Maybe I said this in an earlier interview, and I'm not going to disclose his name, but it is certainly one, if not the most famous vaccinologist on this globe, who told me, Geert, you are right, these vaccines are basically just going to breed variants, but nobody is going to listen to you because you go against the mainstream, right? I mean, imagine. It is just, I have no words for this. Were
you surprised when you got no response? Is this the first time you've reached out with an issue?
No, I was not surprised, no. The Ebola story, I mean, it was the same, but it was a small scale. It was just the countries in West Africa.
What was your job on the Ebola vaccine?
Well, I was coordinating the Ebola program, and part of this was the vaccines. It was not just the vaccines, was also about a number of measures that needed to be taken, to control more or less the Ebola crisis in collaboration, of course, and with WHO and UNICEF and CDC and strengthening health measures, etc. So it was a collaboration between all these international health authorities. But of course, since I came from the vaccine field, I was very much interested in the vaccines that would be deployed and that would be used.
And what was that issue when it came to evaluating the effectiveness of the vaccine and the safety of the vaccine?
Basically, it came down to the naive interpretation of those who conducted the study that the incubation time of Ebola was, well, I don't remember exactly, 10 or 12 days, and that therefore they would not need to start the clinical observations before so many days after the vaccination, after having identified the index case, and then you have the contacts that were all vaccinated. The endpoint was vaccine efficacy after, so many days after the vaccination. But the vaccine that was used was a live vector that everybody knows, and I come from the adjuvant field as well, is very, very strong in inducing inflammatory cytokines. if you study the pathogenesis of Ebola, you will find out that people die of a cytokine storm, of a huge inflammatory cytokine storm. So what do you think happens if people who are incubating this, because you identified the index case and then you were immediately vaccinating the contacts, who potentially were already in the incubation phase and would have been the ideal controls. So these people are already incubating a disease that leads to inflammatory cytokine storm. And then you come with a vaccine that is well known to stimulate pro-inflammatory cytokines. So these people, those who were infected and were vaccinated, they simply didn't make it till day 10 before they started the observation.
Wait a minute.
100%.
So let me get this straight. They basically said we know the incubation to be of Ebola to be about 10 days. Therefore, when we find the index case, the person we know that's infected, they went and vaccinated everybody that had come in contact with them.
Yeah,
but
ring
said-
vaccination. It's called
Right, ring vaccination, ring around the index case. But they said, let's not collect any data for the first 10 days because we know that if anything's going to happen inside that 10 days, it's, it shouldn't count. And what you're saying is you gave an inflammatory vaccine to people that were potentially incubating a highly inflammatory disease. That's what we know, the hemorrhaging, all the issues. You are then creating a perfect storm, these two things coming together, where obviously if someone already had a hemorrhagic disease of huge cytokine and was also driven by the vaccine, those people are going to die. So did you ask to see any data of those that obviously there were potentially deaths happening there that weren't making it into the evaluation of the safety and efficacy of this product? Did you reach out to the WHO to say, can I see the data before the 10 days?
The question was very, very simple. We just wanted to have the case fatality rate over the whole period, as of day 0 from the vaccination, compared in the vaccinees versus the placebo, just from the very beginning, and just compare the case fatality rates. So what is the case fatality rate in the vaccinees versus the placebo, right from start? I was working with Gavi and asked that question to WHO. We never got an answer because it was confidential. And then I remember I was on vacation and my boss sent me this paper in The Lancet, and which revealed that there was 100% efficacy. I immediately knew that there was something wrong. But of course, this was, so to say, small scale, was only West Africa. But just to tell you that this is not the first time that I'm taking a deep dive in such things, because I cannot stand it, that first of all, the science is violated, and that people who cannot, how can laymen understand the science? It's very, very complex, right? For me, it's not even about, freedom or about conspiracy theories or even about, side effects. Okay, the side effects are important, but this is about a global health drama that affects every single individual.
Let me ask you a question that I'm not sure I've seen you answer, but you've done a lot of different interviews. Explain to me, in your understanding, what would have happened had we basically really just done nothing? Had no one ever screamed, there's a deadly brand new, pathogen sweeping the planet. No vaccine product is raced onto the market. What would have happened if we just sort of let things go naturally?
Well, we would have had a pandemic, a natural pandemic, and a natural pandemic that would have primarily or almost exclusively affected, I call them vulnerable people. You know these people, these are typically elderly people who have an immunosenescent immune system, an aging immune system, or people with underlying diseases, or people who are otherwise immune suppressed. The only way to calm down a pandemic is to cut the transmission, and that is only possible through herd immunity. So we would have had a couple of waves. Some people indeed would have died. depending on what would have been the possibilities for treatment of these elderly people and also people who are immune suppressed. And then, of course, you have the young people, typically, I'm saying this is not a childhood disease, who have a very strong innate immunity and basically are not affected at all. They at most develop asymptomatic infection, right? Asymptomatic infection. And then, of course, you have in between people who would not have sufficient innate immunity to be protected against the disease. Those people would have gotten the disease, would then recover, and would then have built a long-lived acquired immunity. So that is typically how pandemics occur. And within 1 year, the virus would not have been eradicated, but it would have been under control. Under control due to herd immunity, to a large extent due to the innate immunity that all youngsters and people in good health have.
Okay, now I hear two terms that I think that many of us have been interchanging, perhaps inappropriately. I hear you saying naturally acquired immunity and innate immunity. And I think many of us are confused that there's a difference between the two. So first of all, is there a difference between innate immunity and natural acquired immunity?
Yes, and what we call innate immunity very often, and I'm very often talking about innate antibodies, in contrast to the naturally acquired antibodies. The innate antibodies, these are pre-existing antibodies, antibodies that are already, so to say, pre-primed, that you have at birth already, not as a result of antigen experience, right? So a newborn all of a sudden gets confronted with a number of pathogens. Yeah, he or she, the newborn cannot have all these antibodies ready because has never seen these pathogens. So this is providing them with a good start. The innate antibodies were found in every vertebrate species, also to tell you how important they are from an evolutionary viewpoint, that they are that you find them in all vertebrate species. So this is something that we have been completely neglecting, and these are basically the antibodies that protect all these young children and people in good health from a disease that is therefore not a childhood disease, right? SARS-CoV-2. So the cells that generate those innate antibodies, we call them B1 cells. It is a particular type of B cells, which is different from the B cells that generate the naturally acquired antibodies. The naturally acquired antibodies are antigen specific, first of all. They do have a high affinity for that particular antigen, and they are long-lived. And they are typically acquired when we talk, for example, about SARS and other infectious diseases. They are typically acquired once you have gotten the disease and you recovered from the disease. And they have high longevity, so they are almost, and even if they disappear, they generate immunological memory. And because they generate immunological memory, they can be recalled very, very rapidly. So that is also some misunderstanding. Many people are worried because their antibodies have disappeared in their blood. They should know that as soon as their body sees the antigen again or is re-exposed to the virus, that within no time, because there are memory cells, these memory cells will again start to produce these naturally acquired antibodies that then will protect them.
So just prior to explaining the difference between the innate immunity and the naturally acquired immunity, you were talking about in a natural infection situation where we didn't have a vaccine, had we just let this thing run its course. I want to just sort of summarize now, make sure I understand this correctly, that you would have had those people that would get get the infection, usually the elderly that have comorbidities, they have other health issues that are bringing down their immune system, their ability to really fight properly, they're going to be at a high-risk situation. Some of them will potentially die because they just won't handle the virus well. Then you have this other group, middle-aged people, they can be different ages, but also that also represent sort of a different immune system strength and ability. Now they're going to get the infection, become symptomatic, and in that process, their body will create these antibodies, the naturally acquired antibodies that have long-term memory. And that's really that's the only immunity we all really have ever talked about. For the most part, that's what we understand. My body sees this virus or a bacteria, it creates antibodies that are supposed, if I have a natural immune system, it lasts forever. If they're induced by vaccines, maybe not quite forever, but for a long period of time is the goal of the vaccine. And then you reference the children as though they have a little bit of a different system. They have an innate immune system, as I understand it, and when they come in contact with the virus, they may not actually ever get to that place where their body is making these naturally acquired antibodies because their innate immune antibodies are so strong and capable that they end up just attacking the virus very well and killing it before there's a need to go in. And I'm guessing all of that talk of asymptomatic that we've heard about, those asymptomatic cases would have been those where their innate immune system reaction was so strong, they never went into a symptomatic reaction, which would have driven more of the production of those naturally acquired memory antibodies. Am I getting that right?
Yeah, and that is why we call it the first line of immune defense.
The innate.
Right? The innate antibodies. What we are talking about, just like in the field of acquired immunity, as you just explained, and you have naturally acquired antibodies. And as some people will know, you also have the cellular immunity, right? So like T cells, for example, acquired immunity. Well, you have exactly the same compartments in the innate immune system. The innate immune system is, of course, more than all this, but you have, first of all, the antibodies, which we call the innate antibodies, and you have also the innate or the natural cellular component, which are the NK cells, for example, the natural killer cells. So it's not like you have no other components in these systems, but if we talk about the guys who are doing the job, who are cleaning up stuff, either neutralizing the virus or killing virus-infected cells, we call about effectors, and that effectors could be antibodies or cells, of course, that kill cytolytic cells. Also NK cells can kill, like T cells can kill.
Cytolytic means kill, like the ability to kill.
Cytotoxic, cytolytic, killer cells, it's all...
Okay, and so one of the confusions that's been happening is that not all antibodies and not all cells are cytolytic or cytotoxic. Some just bind, some just do other things, but they don't actually kill the virus and sterilize it and get rid of it. Is that correct?
Yeah. That is one thing. The other thing, Del, that is also important to understand, and I think it adds value to this discussion, is that if you have antibodies, and now I'm talking both, whether these are naturally acquired antibodies or innate antibodies, sometimes they are not strong enough to really do their job to neutralize, for example, the virus, but they can still bind to the virus. By doing that, they can facilitate the entry of that virus in antigen-presenting cells that then cut the virus in bits and pieces so that the different pieces can be properly presented to the T cells, for example, or to the NK cells, right? And that is how each of these compartments, the innate and the acquired, do have an antibody part, but also a cellular part that both can either neutralize free-floating virus or virus that is inside the cell. That is what the killer cells do. The killer cells, they kill virus-infected cells, right?
I see. I see what you're saying. So you have viruses that are just floating between the cells, still trying to get to the cell, and then you have the viruses that are already in the cells. Those need different functions to neutralize. That makes perfect sense. Okay.
And that is the difference between prevention of infection and prevention of disease. Once the virus is in the cell, I mean, it's already destroying the cell, right? That is what predisposes you to disease. So if you then have killer cells that can kill those virus-infected cells, they will make sure you recover from the disease. Whereas if you have functional antibodies that can readily neutralize the virus when it comes in, you can prevent the infection of the cell in the first place, and you're not going to get the disease even.
So now we've talked about the natural immune system in a natural world with no vaccines involved. What would have happened? You predict essentially somewhere around a year in, we would have seen a real just decline into, a stasis, not necessarily having eradicated the virus from the planet, but have found a balance with it where we have enough immunity and enough people that keep it in check, our immune systems, that it really can't turn it, it's stopped being a pandemic. What would have been a 1 year, clear we're past 1 year, we are still having issues with this virus that appear, and we hear about variants and mutations and these things. What was it about the vaccine that appears to have elongated maybe, or how does the vaccine change that experience or that outcome?
Well, as I mentioned right from the beginning, and I'm just going to repeat this because this is literally what I said at the very, very beginning and what will lead to the explanation to your question. Never, ever, never, ever use vaccines that do not induce sterilizing immunity. So to your point, that cannot prevent infection. Never, ever use this type of vaccines to do mass vaccination in the midst of a pandemic. If you get infected normally, we're not talking about a pandemic, you get infected, there is a viral load, of course, due to the infection, right? And then almost after you have transmitted the virus, very often it's like this, the antibodies start to mount. So the antibodies, the peak is reached after the bulk of the viral replication has already taken place. So that means these antibodies that you generate can no longer put this virus under pressure. It's already gone almost by the time these antibodies mount. If you are now vaccinating people during a pandemic, that means that the antibodies are mounting while they can be confronted with the virus. There you start to put immune pressure on the virus. So these combinations of doing massively, having a population that massively, because you do mass vaccination, put pressure on the virus, combined with vaccination programs that are conducted in the midst of a pandemic, this can only lead to natural selection of the fittest, and because many people are in a similar situation, this variant that then can overcome the pressure will of course be enriched in the population, and it will ultimately become the dominant variant. And you can see many studies have been done. I have a study here from Canada where they introduced mass vaccination, and in August they had 50% of the Delta variant circulating. 1 month later they had 100% was Delta. So we have never ever been saying that these more infectious variants were generated by the vaccines or by mass vaccination. No, they were already circulating, they existed already. But what mass vaccination has done, it has within a short time frame generated an excellent breeding ground for these more infectious variants, so that now their propagation has exploded as a result of the mass vaccination.
I have an analogy for this I've been thinking about a lot. I want to run it by you. Let's say in terms of sort of the vaccine, like this idea of, it's not that it's mutating. It's not like it's like growing arms and legs and things like that. It's that you're just selecting a variant that's already there, but it wasn't the popular one. It wasn't the dominant variant. The dominant was the more mild form of the illness. So in my analogy, imagine you're a scuba diver and you're going swimming and you're swimming in the ocean and there's killer whales in the ocean. Now, the killer whales, we know, rarely attack human beings, but on a rare occasion, they've been known to be hungry and decide to attack a human being. There's also sharks in the ocean. Sharks, we know, love to attack human beings and do it all the time. They're much more dangerous to human beings. But killer whales outcompete sharks. In the situation with killer whales, they can eat a shark, so you don't usually find sharks and killer whales in the same water. But if the swimmer, the scuba diver, decides I'm afraid of the killer whales and that rare risk that I could be killed by them, so the swimmer kills the killer whales, wipes them out, what you do is you take away that environment where they're out competing the sharks. Now the sharks come in because there's no killer whales around, and now the sharks become dangerous to the scuba diver. Much, much more dangerous. They're the more dangerous variant. Now, all we have left is sharks, and now all of us are in danger of getting into the water. Is that sort of...
Yeah, the analogy would even be better if one would say the scuba diver is using a weapon that can only kill,
killer whales.
The killer whales.
Okay.
So the weapon, the immune system, so to say, doesn't work for the sharks.
Got it.
It only works for the killer whales. So he's firing with a weapon underwater, but that weapon doesn't work for the sharks. It only works for the killer whales. And that weapon is the immune system, of course. The sharks can resist. The killer whales cannot resist, right? Yeah.
And so your concern is that the more we vaccinate, the more we're wiping out a virus our bodies could really handle fairly easily, except for a small few, and now selecting for a much more dangerous virus. And this process keeps going. Now, I want to play a clip by a guy named Z-Dog, does an internet talk show, and he interviewed a very famous doctor here, Dr. Paul Offit. I guess he's a virologist. He's invented vaccines or made vaccines. I'm not sure if you've ever come in contact with Paul Offit.
No, he's very well known because he wrote is one of the editors of the most famous vaccine book, together with Stan Plotkin and Walt Ornstein. So,
right.
You cannot not know him.
Okay. So he's a big deal. So I mean, this would be an equal peer. He's asked about your theory on pressuring the virus and making it deadly, and this whole thing that you've been very worried about. This is what he had to say in this interview.
There's a guy, Geert van den Bossche. Have you heard about this guy? Yeah. So apparently a virologist in Europe has his premise, and you can maybe explain it better than me, is that, by vaccinating during a pandemic, we're putting pressure on the virus to emerge vaccine escape variants, and that we've primed our immune system. Therefore, follow-up vaccines won't be very effective. Something along those lines, to paraphrase. Am I paraphrasing that right? And what do you think about this? Because it has a grip on the public, this idea.
I with what evidence? I mean, you have, for example, what can I say? So you have measles, for example. We've had a measles vaccine since the early 1960s. Measles is like this virus, a single-stranded RNA virus. Measles, like this virus, does mutate. Nonetheless, despite 60 years of measles vaccine, we have not seen strains generated that resist immunity from vaccination. I mean, flu is different. Flu mutates on a daily basis. I mean, that virus is a moving target. This virus also mutates, but much slower than, say, influenza does. We'll see. I mean, it's like, the notion that you're creating you've created a population, either from natural infection or immunization, that is likely to have several years of protection. That's a good thing. And although this virus may mutate to the point that it escapes recognition by current immunity from vaccination or immunization, then you come up with a second generation vaccine. That's what you do. I don't think that's going to happen, actually. I think that the viruses, there's probably been already about 12,000 mutations on this virus already. I mean, and I think you may get to the point if they're resisting all immunity, or meaning that it's as if you never got the vaccine, you never got naturally infected. I think that's probably a lethal mutation.
Yeah. So in other words, you're kind of running the runway out on the virus's ability to change
That's
itself.
right. Lethal
Yeah.
to the virus, not lethal to us. Right?
That's right. Lethal to the virus. Right. And so within that parameter, then I think, again, it's another compelling reason to just go and get vaccinated now.
So he says you're wrong. He, as we just heard, said that that just like measles, this is a single strand virus, that we will achieve immunity the same way that we did with measles. He says the flu does have more, like it mutates faster every day, he said, but coronavirus not as fast. I find it sort of ironic that at the end he says it's already, mutated 12,000 times. There's 12,000 variants or something. At least to a lay person, that sounds like a lot, but I don't know. But what about it? I mean, in the end, he says you're going to have immunity for several years. And should there be another variant, all we'll have to do is make a new vaccine to deal with that variant, and we're good to go. Why? I mean, that seems to be the thinking of almost every, scientist working for governments around the world. Where do you differ with that perspective?
Well, I mean, the conditions, remember the sentence that I just repeated, which was really my concern, and which was already in the first call that I made. Conditions are not fulfilled. Have you ever seen mass vaccination across all age groups against measles?
No, not that I know, because what I think about measles,
we vaccinate children against
Right.
measles. And why do we do this? Because measles is a childhood disease. And basically, remember about the innate antibodies. If the infectious pressure, you probably know that measles is very, very infectious. It's amongst one of the infectious viruses
Yes.
we know. So it breaks immediately through the innate immunity. So if you don't come with a vaccine, you cannot stop this thing. Second, what I also said is never ever vaccinate with vaccines that do not block transmission during a pandemic of a highly mutable virus. I mean, measles is not a highly mutable virus. Can be an RNA virus, but it's not a highly mutable virus. Influenza is. And I bet you, if you would do exactly the same with influenza, so conditions need to be fulfilled, you have a pandemic, you start to do mass vaccination with vaccines that cannot block transmission, you will end up with exactly the same situation. So people are comparing things that are not just comparable. I hear people saying all the time, why don't we have this with flu, etc., etc. We have herd immunity with flu. And so from time to time, immunity weakens and then you have a breakthrough. But guess what? I mean, as soon as the flu starts to spread, it encounters either young people who have very good innate immunity, who will block the virus and who will even eliminate the virus, or you have people who have previously been ill and have mounted long-lived antibodies against the flu that even have broad spectrum very often, right? So this is a completely different situation. We have never been doing mass vaccination of measles. I mean, across all age groups.
Okay, so you're saying that essentially measles, we never, and this is shocking, I think, to a lot of people because we don't really think about this. And I've watched you speak so many times that it's now sinking in that measles, as an example, had already gone through a very big spike. It was very deadly early on, right? And it was already sort of, our natural immune systems had brought it down. The death rate was way, way down. By, I think, 1960, in America, 1 in 500,000 people in America died of the measles every year. So very, very low death rate. I think that of the infected, it was something like 1 in 10,000, if I'm right, or something like that, of people that caught it. Now, then we started the vaccine program. We started the vaccine after really all the elderly, all of our parents, all of the, even the youth had already had immunity. So all you needed to do was to vaccinate the new entries, the children, before they got it. And they said, look, it works. We have herd immunity. But they were really relying on that naturally acquired herd immunity that was being carried by the entire planet prior to vaccination, correct? Okay.
Exactly. So you vaccinate in such a situation. It's the rule is very simple. You only vaccinate the vulnerable people. So in some cases, the vulnerable people are the children. In other cases, like SARS-CoV-2, the vulnerable people are rather the elderly. So in other words, the answer to your question is, I do not rule out that if in case we would have done this, as you were just explaining, with measles, really mass vaccination across all age groups, when measles came in as a new virus, that we might have seen the same problem occurring. You understand what I'm explaining?
Yes, I understand that. Now, my last question on the measles comparison by Paul Offit. You said that this vaccine we're using for SARS-CoV-2 is only prophylactic. It really only protects the person from severe disease. It does not neutralize the virus. Does the measles vaccine neutralize measles, or is it similar in that it only reduces symptoms?
Well, it will. The measles vaccine, because this is, of course, the other difference. We have not even been talking about this. People talk about vaccines as if they were all based on the same principle.
Right.
We need to distinguish between live vaccines and subunit or killed or whatever. But live vaccines, that is, of course, very, very important, because what will happen with a live vaccine is that you will have also strong stimulation of your innate immunity that can induce indeed sterilizing immunity, right?
Yeah.
So innate immunity can indeed be sterilizing. But that does not mean that you will eradicate measles, for example. Same, we had the same with polio. Remember, polio was a live attenuated vaccine. Did we eradicate polio? We didn't. We came close to it, but we didn't. Because you can still have transmission by asymptomatic people, for example. So you will control it much more easily. Why? Why will you control it much more easily with a live vaccine? Because you will have a lot of innate immune stimulation that sterilizes. We were just talking about innate immunity, how effective it is.
Yeah.
Because in contrast right now with the vaccines and with the antibodies that cannot control the infection and the transmission, innate immunity can. That is why this innate immunity is so super efficient. So if you now have a virus, a live virus that can do this, it will be much more efficient.
Okay, so in Paul Offit's comparison, these are really apples and oranges. You have what we believe to be a highly mutable disease in the SARS-CoV-2 and a less mutable disease in measles. At least we believe. We won't know because we're looking at two totally different environments, one very pressured, one not. But that's the general assumption. And the vaccine is different. A vaccine is different. A live vaccine that induces a stronger innate immune response, which really does, neutralize this virus. Maybe not eliminate completely, but it does a much better job than the vaccine that we're talking about now for SARS-CoV-2. Correct? And so those two things.
Yeah.
Now,
No, three things. And we didn't do mass vaccination.
We didn't do mass
across all age
vaccination.
for the measles. It's a very important one because that is where the immune pressure comes from.
okay. Now, the last part of this, though, is Paul Offit says it doesn't matter if you're right, Geert. It doesn't matter because even if we have selected for a variant and at some point that variant ends up becoming the dominant strain, at that point we'll just make a new vaccine that handles that variant and end of the problem. Why is that an issue? Because that seems to be what the FDA and everybody are sort of counting on. You're seeing studies that are talking about, well, this Delta is getting problematic. We may need a new vaccine in the future. Why are you worried that that's not going to happen? That's clearly what's going to happen. So why won't that save us?
Well, what Paul Offit is alluding to is the influenza strategy. And again, I'm always repeating my only sentence, my only call. do not vaccinate with non-sterilizing vaccines during a pandemic. You know, I mean, I'm always giving the example, you are loading your gun while you are already on the battlefield, while you get already attacked, right? If you do this before you get attacked, there is no problem. That's what I was saying. Normally, when you get infected, a natural infection, virus comes in, there is transmission, and it's only afterwards that the antibodies peak. So the antibodies cannot really put this virus under pressure. But if you now vaccinate, and you vaccinate these people, I mean, you don't give them quarantine till they have full-fledged antibodies. You don't tell them, stay at home for at least 6 weeks because you need your first shot, you need your second shot, and it's all going to take at least 6 weeks till you have full-fledged antibodies. These people go out, and the next day or the next week, they can get attacked by the virus. Why? First of all, it's a pandemic. Second, we are now dealing with a new pandemic. This is a pandemic of highly infectious variant. This is a pandemic of the Delta variant, right?
Right.
So it's a completely different. Again, the conditions are not fulfilled. Comparing apples with, oranges or whatever.
I have another, and just because I try to help my audience and I think simply, but when you're talking about the antibodies needing that time to develop, I imagine a war. If we're in the middle of a war, the best way to handle a war is you send your cadets through basic training. They get boot camp, they get fully trained, they get all their gun training, they're working out, and then they're strong soldiers so that the moment that we send them off to attack, they're at the best capability of winning that war. But if in the middle of the war, we decide, you know what, we don't have time or for whatever reason, we just skip, or in the middle of boot camp, we just send these children in that haven't worked out, they barely know how to work their gun. Now they're in the middle of the fight. They're coming to the enemy. That enemy is just going to overrun them and come plowing through and wreak havoc and win that war. Is that sort of a, when you talk about...
Yeah, of course.
Okay.
Yeah. When it comes to fighting pathogens by the immune system, we always compare this to war situations or soldiers. It's an analogy that works out pretty well, yeah.
You'd like to see us stop this mass vaccination campaign because it's causing the pressure you're talking about. And Paul Offit's approach with mass vaccination is going to create a variant that each time we then vaccinate for, we're going to create a more and more infectious and potentially create a problem. Is the fear that one day there'll be a pathogen that we just can't, there's no vaccine can stop it? Is that basically the concern?
When I read peer-reviewed journals from, molecular epidemiologists, right? I mean, they are simply predicting this, and I cannot understand. It's like I'm telling these things, but if you don't mind, I can simply, citations, peer-reviewed journal by, this is like Harvard Medical School, the Dana-Farber Cancer Institute, MIT, etc., right? And there are statements like, and this is published early this year, when neutralizing antibodies are broadly present in the population. Broadly present in the population is when you do, for example, mass vaccination. Population level selection for antibody evading infection competent viral mutants may result in rapid resurgence of SARS-CoV-2 infections. So that is one thing that we see right now, the resurgence of the infections, right? I mean, this is a very strange situation where we all of a sudden see in all these countries where we have this mass vaccination, we see an increase in infectivity. But to your point, to the resistance. So what this paper says as well is evidence from multiple experimental studies suggests that specific single mutants may be able to evade spike targeting vaccinal immunity in many individuals and rapidly lead to the spread of vaccine-resistant COVID-2. One variant that can escape convalescent plasma neutralization is already in South Africa. This was beginning of this year, and could experience greater positive selection pressure once vaccines are deployed widely. Finally, the overall size of the pandemic in terms of number of active infections will play a significant role in whether the virus can be brought under control with vaccines. The speed at which neutralizing antibody resistance develops in the population increases substantially as the number of infected individuals increases, suggesting that complementary strategies to prevent SARS-CoV-2 transmission, for example antiviral prophylaxis, and that do not exert a specific selection pressure on the virus, are key to reducing the risk of immune escape. In this context, vaccines that do not provide sterilizing immunity and therefore continue to permit transmission will lead to the buildup of large standing populations of virus, greatly increasing the risk of immune escape. And I mean, there are other publications, I don't want to take too much of your time, where it is very, very clear. I'm not the only one, I'm probably the only one who dares to speak out. But I mean, these world-class molecular epidemiologists are very, very well aware and have been warning at the beginning of this year, I must read this one, that the emergent and rapid rise in prevalence, and this was of the alpha, beta, gamma, has prompted renewed concerns about the evolutionary capacity of SARS-CoV-2 to adapt to both the rising population immunity and public health intervention such as vaccines and social distancing. As a consequence, the epidemiological and immunological properties will likely complicate the control of COVID-19. So, I mean, this is not new. People know, people have seen already that before we even started the mass vaccination, the virus was already under tremendous pressure, most likely because of high infectious pressure in areas that were very densely populated, like in South Africa, the Mandela Bay, or in Brazil, in the favelas, etc. And because of that, there was a high local immune pressure, but this pressure was directed against the spike protein. And it has already they have shown that the many mutations in the S protein were really driven by immune selection pressure exerted by the population. Now, guess what? We are now coming with a vaccine, the target of which is the spike protein, and the spike protein is the target of the infectiousness. So now if I'm saying I'm exerting immune pressure on top of the pressure that existed already before the mass vaccination, I'm exerting pressure on the infectiousness of the virus, because that is what S is doing, making the virus infectious. So then, if that is the case, I would expect an explosion of more infectious virus. And that is exactly what we are seeing.
Why doesn't Paul Offit, if you say everyone knows this, if you're in immunology, you should know this, why doesn't Paul Offit know this?
I don't know. Sometimes, Del, I mean, this is my personal opinion. I'm not saying that this is the case. Sometimes I'm under the impression that the establishment, you have always an establishment, you have this in vaccinology, in immunology, in all branches, in all disciplines, that the establishment thinks, well, you know, we have made it, I've made my reputation, my name, my career, and just based on my knowledge, I'm going to draw conclusions. If you are tackling a very complex problem, like a pandemic, and you intervene with infection prevention and with vaccines, and you think you can afford yourself to leave stones unturned, I mean, then for sure this is a recipe to make big, big mistakes. So with all my respect for these people and what they have been doing, but even world-renowned professors are making right now big, big, big mistakes because they are not doing their homework, or because they cannot draw from all these different fields, and immunology, and virology, and vaccinology, and evolutionary biology, etc. And if you don't do this, if there is one field that is missing because you think you are a virologist and not an immunologist, and you think I can explain this from the viewpoint of virology, then you have no right to speak. You have to familiarize yourself with those disciplines if you want to say your word in the analysis of the pandemic and certainly how to tackle it.
Okay. I want to get into, where I was sort of setting this up is you're in two camps. It's clear you've laid out a very clear issue with mass vaccination and the pressure of it. But there are people on, that watch my show that reach out and say, he's saying that natural immunity is flawed too, that there's a failure in natural immunity because that the innate immune system has these sort of temporary or short-lived antibodies that, just like the vaccine induces specific antibodies that get in the way of the innate immune system's fight. I've heard you say that there are people who have already come in contact with the virus, have had their innate immune response, that are getting reinfected. You're saying that's happening with the kids now that we're seeing, even though, and I want to say this, even though on my show, I'm presenting all sorts of science coming out of Israel that shows that there's long-lived, robust protection from natural immunity. It is far better than the vaccinated immunity. Every study is showing us that. Studies out of Israel show that I think the reinfection rate is less than 1%. Yet you've been pretty vocal about your concern about reinfection. So what are you saying that's different than what we're seeing in these studies in Israel, saying that it's less than 1%, virtually non-existent, this reinfection problem? Are they the same problem? Explain it to me.
If that would have been the understanding of your audience, I absolutely need to correct this. I'm certainly not at all against naturally acquired immunity. But there is two things. First of all, the reason why now many people get reinfected, so to say, is because after asymptomatic infection, you develop short-lived antibodies. Remember, do you remember the story in Manaus in Brazil, where they got a huge wave at the beginning of the pandemic, and then they started measuring antibodies. And they said, we have herd immunity. Almost everyone was positive. Guess what? A few months thereafter, they had the second huge wave, right? But the problem is that many people must have developed simply asymptomatic infection. Of course, their antibodies will last for about 6 to 8 weeks. But those who had really gotten the disease and acquired the long-standing antigen-specific, the long-lived antigen-specific antibodies, they were, of course, protected.
I want to be clear. You're really differentiating between an asymptomatic infection and a symptomatic infection. Once we're into a symptomatic infection, that cues us that you've now getting that B cell created antibody, memory antibodies that will remember that experience and fight the virus should you come in contact in the future. So once we're symptomatic, we're having a much stronger reaction, and we develop long-lived antibodies that have memory. Whereas you're saying if you're asymptomatic, your innate immune system did such a good job that you have these antibodies that don't have memory and they're short-lived. They only last for 6 to 8 weeks to do their job, and then they're out of there and they're gone. So what you're differentiating between is an asymptomatic and a symptomatic infection. Very different in how our immune systems deal with it.
As an asymptomatic infection, you only see the antigen a few days, right? The virus is rapidly eliminated. So your immune system is not really primed. It has seen it, there is some activation. There will not be long-lasting, no memory, etc., etc. So the immune system had seen it, but then it wanes very rapidly.
Now, it's interesting when I was looking at this, Geert, because at first, when I heard you say this several times, it seemed like a flaw in the immune system, that it makes these short-lived antibodies. But it occurred to me, whether or not you believe in God or perhaps just in evolution, you can come to the same realization that it appears to me that there's something brilliant about this innate immune system, that it is so short-lived. Because maybe I'm just going to run this by you. This is just me sort of thinking it through. Perhaps with something like measles, where the innate immune response is never strong enough, it's always going to roll over into that more robust, long-lived immunity because it's not highly mutable. And that makes sense that if we want to survive, I only need to catch that once. And so I want to have a specific response. I want to have a specific antibodies built that will always recognize measles because it's not going to change that much, and that will last me my whole life. But when it comes to upper respiratory illnesses that we've had a real difficulty making vaccines for, the major reason is they are mutable. They change a lot. And so whereas you would want long-term immunity for a virus that's stable and going to stay the same, you don't want a long-term immunity for a virus that's changing all the time and producing variants, because at some point it's not going to recognize it, and now having those specific antibodies is going to be a problem for you because you won't recognize the virus coming in and then are really vulnerable. So our immune system has this brilliant function where in viruses, especially upper respiratory, that mutate very quickly, it only wants a quick reaction. It grabs on, we have NK killer cells hit it, our innate immune antibodies hit it, and then there's these, to mop it up, these short-lived antibodies, and it's great because they clear out of the way, and they're gone. And it's like the whole thing never happened. And so in many ways, that innate response is the best response. And so my question would be now, as we look at the environment that we're seeing for the natural immunity versus innate immunity versus vaccinated immunity, we understand, I think, all the problems with vaccination immunity. It doesn't stop the infection, it doesn't stop the transmission, it doesn't neutralize the virus, and therefore just creates pressure and allowing it to be a breeding ground. And so in some circumstances, as this vaccine's pressuring and we've created this unnatural world, we really want as many people to not have come in contact with this, right? Or to have at least been asymptomatic so they still have this innate immunity in place and not naturally acquired. Are we in a situation where there may be a preference, just as a scientist looking at this bigger picture, that the innate immunity may be the more important immunity right now compared to the naturally acquired immunity for these reasons?
Yeah, well, certainly for this type of disease, because as I was saying, it's not a childhood disease, and typically the innate immunity is more than sufficient. And in fact, the acquired immunity, as you were saying, is only very important if you have a situation where the innate immunity is not really sufficient. I wanted to make a small correction to what you said. The vaccinal antibodies, they can also, of course, and neutralize. The problem is that the neutralizing capacity is, of course, not so good because the vaccine that we are using is pretty different, the S protein, from the S protein in the circulating strain. The big advantage of the natural infection, you get immediately the update. You get infected by the most relevant variant that is circulating, so you get immediately that update, and secondarily, it primes in a much more efficient way so that the diversity of variants that it will recognize, that your immune response will recognize, is larger than the one that got induced by the vaccines. So that are the two major advantages. Right? Okay. I don't want to make things complicated, but it is somewhere a kind of innate response that is between the purely pre-existing, that has no memory, is broadly protective and cross-protective, and the one that is the acquired, that is very specific and has memory. You have something in between, and all this is documented. These are kind of like innate antibodies that have already some kind of maturation, not really memory, that are a little bit more narrow in what they recognize. And these people who keep in good shape, etc., they do have this kind of innate, trained immunity. And you will see, and I tell you, and everybody can write this down, the immunity will become, of the unvaccinated, will become better and better. Thanks to training, they're continuously confronted with the virus. And so what you will see, and you can already see this in the graphs that are published by the Public Health England, In the vaccinees, the efficacy or the number of the infected and diseased people remains more or less the same. But what you see is that in the non-vaccinated, the number of infected people becomes lower and lower, and because the infection diminishes, because what I'm saying, innate immunity, whether it is trained or pre-existing, is sterilizing immunity. So because it gets trained, you get less and less, fewer and fewer infections in the unvaccinated. If you get fewer and fewer infections, you get, of course, fewer and fewer disease cases. And you see the number of disease cases in the unvaccinated going down. And what will happen is that, and that of course also applies to children, what you will see with the children is that even though we continue the mass vaccination, you will see that their trained immunity, their innate immunity is going to be more and more better and better trained. So guess what? These experts who don't understand anything about the evolutionary dynamics of the pandemics are saying, yes, we have low cases, disease cases for the kids, but we need to vaccinate them because look, we have a tremendous impact on transmission, right? Of course, as these young people get the innate immunity more and more trained, these antibodies now can be less well outcompeted by the short-lived antibodies. And you simply go to the publication of Public Health England. You can see, Del, on the left panel, the vaccinees are the black columns.
Yes.
And the non-vaccinated are the gray columns.
Great.
Okay, the first three columns, it's under 39. You see an effect of the vaccine on infection, Del. Okay?
Yep.
The vaccinees, there are fewer vaccinees infected
Right.
than non-vaccinated.
Right.
People under the age of 30 or 40 even, the vaccine has a dramatic effect on the reduction of transmission. Then I would say, wait a minute. If I'm going to wait for like 1 month, then these people, their innate immunity must have gotten trained a lot better because the virus is circulating all the time. And then you look at the graph at the right panel. What happened? So now in the age group 30 to 39, it's already the unvaccinated that got less infected. And in the other group, 18 to 29, it's more or less the same. There is a little still advantage of the vaccinees. And still in those who are very unexperienced in terms of antigen encounter and maturation of their innate immune system, so the youngest children, there is still a major advantage of being vaccinated. But I tell you, if you're going to look at this column, under the age of 18, you will see in 1 or 2 months from now that also there it will dramatically decrease, and it will maybe even be at the favor or at the advantage of the unvaccinated, because even those young children or young people will now get trained more and more and will be capable, thanks to their trained innate immunity, to have sterilizing immunity and eliminate the virus. If we are now going to vaccinate these people, what we are going to do is that we will take away this capacity of sterilizing immunity.
Then we leave a population that nobody can sterilize.
Yeah, we can completely forget about herd immunity. Can you imagine what this means if you are now going to suppress this innate immunity on a permanent basis? Because that is exactly what you will do if you immunize them, if you prime them, right? Secondly, they are a breeding ground for the more infectious. So this is just going to speed up the resistance. And third, when the resistance comes, I mean, these people will have their innate antibodies completely suppressed, and their acquired antibodies through vaccination are completely worthless. Can you imagine what that means for individual health and for the population health? This is just going to be a major disaster. And Del, Nobody can explain this. I'm explaining you what is happening there. And, nobody cares. Nobody interprets this. This is just, for me, this is unbelievable, unbelievable.
Well, this is probably, when we watch this FDA meeting, to me, you didn't have to be a rocket scientist or even a virologist to say, that just seems very simplistic and perhaps stupid. When I think this comment was the one that really went wild on social media, and I think really ends up being the grounds for why the FDA appears to have, agreed to authorize the use of this vaccine in children. Take a look at this.
We're never going to learn about how safe the vaccine is unless we start giving it. That's just the way it goes.
There it is. We're never going to learn what the vaccine does till we start giving it to all the kids.
Del, let me put it that way. You can talk about many things. You can talk about, of course, all the side effects, and that is important. I'm not saying that is not important. And that is, so to say, the safety. Already the fact that they are saying, we use human beings and even children as, experimental animals, but basically to see. But one thing that we do know, and the safety impact, because he's talking about safety, the safety impact will be tremendous and will be of an order of magnitude that is not even comparable to the side effects we are talking about, is driving this virus into resistance, depriving the children from both their innate immunity and their vaccinal protection, and preventing in an irrevocable way the population from ever generating herd immunity. So what we are going to do is, instead of the population exerting selection pressure on the virus, we are going to allow this virus to exert selection pressure on innate immunity of the host. So that means only people who will still have their innate immunity intact have a chance to survive.
What is the worst case scenario if you sort of game this out? What type of damage in numbers on a population level are we talking about? Because you've seemed very stressed in the videos that I've seen. I can tell right now you're very passionate about this. What is sort of your worst case scenario concern?
I cannot talk about figures, but what is clear is that the order of magnitude will be something completely unprecedented. Because again, what I'm saying is, and this is the logic of the science, what we will obtain if we do this, if we continue the mass vaccination, we continue the boost, we don't do anything about the infectious pressure, we immunize all the children. If that is not going to be a catastrophe, you can put me in jail. I'm very serious about this. Is there any expert who would dare to say this? If I'm wrong with the vaccination of the children, you can put me in jail? Nobody. I do this because I'm convinced, I've done my homework, I've turned this thing upside down from all sides. It is like pieces of a puzzle, of a very complex puzzle that can only match in one single way. If it scientifically makes sense, and then you see all the data, and the data go exactly, none of my predictions, of course, I cannot say January or February or when is this going to explode in Israel. I know it's going to explode. I know it's going to be very fast. I think before the end of the year even, but I don't know for sure. But this is really, we are giving the virus an opportunity to do a natural selection amongst the human race, those who have innate immunity versus those who have none. Right, none left, because of what I explained. I know this is very strong. You know me in the meantime. I'm not into sensation. I'm not into but it cannot be. It cannot be that we vaccinate the children. It's impossible. That is our last hope. It's our last hope.
Well, Geert, we have put a lot of time in here, and it has been very enlightening. And I really feel that I have a great understanding now of your concern. It seems like a very well thought out concern. You've backed it up with evidence, which we've shown here today. And so to me, You appear genuine. The question will be, I suppose, is Garrett right? Are his theories correct? And I think we're in an unfortunate position where we're going to have to choose a side. We're either going to have to choose a Paul Offit, or we're going to listen to Geert Vanden Bossche. And I would say under those circumstances that it's an easy decision for me. There is no risk to our children. We already know in the FDA meetings, they're concerned about, myocarditis and pericarditis, issues that we know are problems with the children. Right there, there's a risk already. But I do think when you speak of it, that risk would pale in its impact on our children and perhaps on our species if what you're concerned about ends up coming to fruition because of, as you've described it, a colossal mistake in science that could lead to a tsunami of morbidity and mortality. And so, Geert, I want to say that whether or not you've nailed every part of this, you've clearly thought about all of it. I will say that I don't see the risk in listening to you right now. I see great risk in not listening, because should you have that moment of "I told you so," when I hear the passion in your voice, I'm horrified at what this world looks like the moment all that is left is your "I told you so."
Yeah, and thanks to you, Del, for giving me the opportunity to speak on that platform. And frankly speaking, my biggest anger is indeed the refusal for discussion and an open debate. That is, I'm beyond angry, because this is where we could have clarified. In the meantime, it has gone progressed that far that it seems to me like this is something we can completely forget about. A dialogue, an open scientific dialogue, even open to the public. I don't know what the courts will do, because there you have case against case. And as I told you, if you have you take a snapshot here and you take a snapshot there, who's going to win. And so my choice has been to do at least an effort to explain as good as we can, and with help of some people who can make the message easier to understand, to reach out to the people themselves, because at the end of the day, they are the ones who are really concerned, very much concerned by this. It's their health, it's the health of their children, and they need to make decisions, or sometimes even coerced to make decisions that they have no clue what the impact is going to be, not only at the short term, but also at the longer term. So to the extent that you can help us reach these people, I'm really very, very grateful to you and your team. Thanks.